Hello and welcome to a new session with edupediaworld.com, your favorite online destination for all your educational needs. Today's session we are going to start with a new topic, and this is the most fundamental topic of descriptive statistics. We are going to start with the measures of central tendency. Now, what is the meaning of central tendency? Well, a set of data usually cluster around some central value, and this phenomenon is called central tendency of data. It is in fact a typical value around which the other figures congregate. In other words, we could say that it refers to that single value of data which could represent the whole data. Yeah, now you must have got an idea that whenever we have a cluster or a set of data available with us, it could be anything. It's difficult to present the whole set of data for an analysis, and so what we do is we take a representative of the data, and that representative is nothing but central tendency. So what are the common central tendency values we have? Well, the most common central tendency value is the arithmetic mean. And you're well aware of arithmetic mean, or simply called as mean, which in our common terms we know as averages of data. Yeah, we also have two other common central tendency values which we are going to study, and they are the median and the mode. Today's session we will confine our study to the first one, that is arithmetic mean. Now, why do we need central tendency values? In other words, why do we need a representative of the data? Well, the first is to summarize the data. Usually it's difficult to present the whole set of data if it is huge, and so we use this single data to summarize. The next, when we have a representative of data, and if say we have more than one set of data, this helps us in comparison. A simple example: is suppose we have two different classes, and say the marks in a subject is taken, and if it is to be analyzed which set of students have performed better, we find the average of both these sets and see who has got a higher marks. In the most simplest form, we can use it for comparison, and apart from that, it always helps us in decision making. And that's the central function of statistics. Here we can use again different set of data, find the averages, and based on the averages we can take decision in business or almost everywhere. Alright, so now let's move on to see how to measure these central tendency values. And today, as I said, we are going to start with arithmetic mean, or simply called the mean. The symbol for arithmetic mean is a X with a bar at the top. Okay. Now we have already seen that the data could be presented in different forms. First is the raw data, which means the data just collected and written as we have got without any tabulation, without any classification. Say for instance I go to a class and there are 10 students, and if I want to find the average of the marks of these 10 students, I just collect the marks and write them. Say out of 20, say they've got 10, the second student 12, 15, 11, 5, 18, 7, 17, and so on. 18 again, and say for example 15. So these are the marks of the students. When the data is presented in this form, it's called the raw data. Now to calculate the average or arithmetic mean of a raw data, what we do is simply add the data. Now we represent data with a variable name x. So we add the data. This is the symbol for addition, that you'll get used to the symbols which we are going to use here. So we'll find the sum of the values here and divide it by the total number of data which we have. So we have 1 2 3 4 5 6 7 8 9 10. So n number of data is 10, and then what is the sum of the data? Let's add this. So it will be 10 plus 12, 22, 37, 48, 53, 60, 71, 78, 95, 95 plus 18 plus 15 makes it to 128, and that will be divided by 10, which makes it 12.8. So this is basically the average or the central tendency value, which now we can say that this class, the students of say this class, my first class, on an average have scored 12.8 percentage of marks. 12.8, of course it's not in percentage because it's not out of 100, but 12.8 on an average. Now I've summarized. In case if I have another set of class, I can make a comparison, and based on that of course I can take any decision. So this is raw data, and in the simplest form it's easy. The formula to calculate the average is simply summation of x, the values, divided by the number of data. Okay, but now we also have data in other forms. We have data given in frequency distribution table, something like this. You have the data given here, x in this column, and you have the frequency or say number of students given in another column. This is a simple example of age of students in a school. Students age are starting from 5 and it is up to 14, and the number of students in each of these categories are mentioned here, which we simply call as frequency or f. Now if we are asked to calculate the arithmetic mean of this data, what we do? Well, are we going to add the values of x here as in the previous case and then divide it by the sum of say frequency or the number of categories which we have? No. Here what we do is we'll have to understand this. When we classify the data in a frequency table, what we mean is that these are the number of students who have their age as 5. So it's not one student whose age is 5, but there are 25 students with a in the group age category 5, and so we will have to add this 5 25 times. In other words, we will have to multiply 5 by 25, and that will give me the sum of the age of all the 25 students in this category. I'll have to do the similar treatment with all the other categories, and only after I find the sum of this, so what I'll have the product of these, I'll have to find x multiplied by f, and then of course I'll have to find the sum of the frequency. Let me add that here and see how many students we have in this category. We can simply use the function sum in Excel here and add. So there are 670 students in total, and not as we thought here that say 10. We have 670 students, and the total sum of their ages, we'll again have to first multiply the ages with the frequency. So in the first case it is 5 multiplied by 25, and so on. So we can just drag the same formula into all our cells, and we get the product of age and frequency. And finally we will have to add all of these, which again we can use this, you can just drag this function and drop it into this cell. So the total sum of the ages of the students in this class happens to be 5918. Okay, had we taken them individually, it would have been simply 95, and this is wrong. So these, let me write that here, this is the sum. So we've got the sum of this as 5918. And now how do we calculate the average or mean? Let me write that here. Mean, or arithmetic mean, simply called as AM, is the sum of the product of age and the frequency divided by the total number of students in the school. Yeah, so the mean here is 8.832. This is the simplest way of calculating, and we call this as the direct method of calculating arithmetic mean. We do have shortcuts like deviation and step deviation methods, which we will be taking after discussing one more category of data, that is class intervals, when the data is given in grouped frequency. Well, here we see that we don't have one individual data in category X. In my, say here we have taken the marks of the students and I have summarized them. So the data is summarized even before we could find the average, and we have given the classes. This here means that there are 3 students who have scored between 0 to 10 marks. Further, there are 8 students whose marks are between 10 and 20, 12 students in this class interval of 20 to 30, and so on up to 100. How are we going to calculate the arithmetic mean of this data? Well, again, the total number of students which we have is not 10 as we see here, but it is the sum of the number of students, that is sum of the frequency. So we will have to find the sum of all of these to get the total number of students. We will again use the same function, sum of the cells from here to this, and well, we see that there are 100 students in the class. Well, but the specific marks of each student is not mentioned here. In this case, what we do is we take a representative of each class, and again that is the central value or the mean. So if we take the mid value, say let me mid value or the central value of this class, it is 10 minus 0 divided by 2, which is 5. The next one, it's 20 and 10, so between 20 and 10 it's 15. 20 plus 10 divided by 2, which is 15, and so on. We see that the next one would be 25, 35, 45, 55, and so on. So these are the mid values, and we are just taking this as a representative of this class, because we see that there are certain classes where the number of students are, say, 10 and above, 12, 15, 18, and so on. Now when you find the averages and the marks of these students are in this class. So if you find the average of all of these, somehow or the other it will come very close to the mid value. So we take mid value as the representative of each class, and that is the way how we proceed when we have class intervals. And now it's simple. We'll go back to the formula which we had. This mid value will be treated as x, and will not take this as the x. Okay, so now we'll find the product of x and f, which will be x multiplied by f, and here in this case this is our x and this is f, so simply use the function x multiplied by f and we get the product. We will just drop this function to all the cells here in the column, and then finally add it. So the sum here is 4750, and the arithmetic mean would be this 4750 divided by 100. So 47.5 is the arithmetic mean of this data. Alright, so let me just summarize the formula of what we have learned today. The first topic we have seen is arithmetic mean. We represented by x bar, and the simple formula to find the mean is the sum of the variables divided by n when we have, say, raw data. Okay, when we have data in frequency distribution, we will find the sum of the product of x with frequency, and we will divide it by the sum of frequency, which in other words we can write as summation of x f divided by, say, let me call this as capital N. This is for frequency distribution table. Okay, now when we have grouped frequency, again the formula is the same, but the treatment is different. For grouped frequency, you have the same formula, but what we do is we don't take x directly, we take the mid value of the class as our x. Okay, so this is the simple way of calculating the arithmetic mean, and we call this as direct method. Direct method of calculation. In the upcoming videos we will see more complex ones when the data is enormous, when calculation directly is difficult, because here we saw that the sum total of in each of the problems which we had taken were a product of 10, say 670 or 100, and so the calculation was easier, which may not be the case every time. So if the data given is complex, if it is in decimal or so on, how are we going to do? We will use the shortcut methods, and we will see two methods under that. The first one is your deviation method and the second is step deviation method. We will see that in our next video. Keep watching edupediaworlds.com. Thank you.